All right, worksheet 4. All right, so we have a derivative f prime shown to us. F of 10 equals 5, and we have we see a bunch of triangles that of these regions between the graph and the x-axis. Okay, we have g prime, and g double prime to all be differentiable functions. Okay.
Okay.
Find f of 4, find f prime of 7, and find f double prime of 7. Okay. So let's first talk about the region that we're interested in. We just care about regions between the graph and the x-axis, so we don't want to be shading in the wrong portions, right? So just between graph and the x-axis. All right. Even though there's a triangle here, this is not part of the region we're interested in because this doesn't involve the x-axis. Okay. Okay. Find f of 4. Now we know that we're going to have to involve areas of these triangles here. So let's just go ahead and find one of them. I think once we find one, they're all going to be the same because they all have similar dimensions. So I'm just going to fill these in, and 1/2 base times height here. That's base of 2 and a height of 4. So that's going to give me -2. Oh, sorry, -4. And if you look, all these are similar dimensions, right? 1/2 base times height.
Mm-hmm.
So you just fill all these in here. In case it doesn't show up. Okay. All right, so we want to find f of 4. Notice that there's no explicit formula for find f of 4. So we have to rely on final position equals initial plus displacement.
Oh, thing you showed us in class today.
Right, right. So I have to rely on this here. Okay. I'll zoom in.
And so our given would be
Mm-hmm.
It's
What's
not
good?
f of 4. Right? What? Oh wait, f of 10.
There we go. Yeah, that's our starting point. It could be anywhere. It doesn't have to be at the left endpoint. It doesn't have to be the right endpoint. It could be somewhere in the middle. Okay. Formula says we need our A values to be in the right location. So we're going to start at 10 and we're going to go backwards to 4.
Now we flip that.
Yep, and now we flip it because we followed the rule, but now we're staring at this going, all right, I prefer to read the graph from left to right. All right, so to resolve that, to make it easier for us to interpret, let's flip it and push a negative in front.
So now we're ready to plug in, right?
Right, so now we're ready to get this down to a numeric value.
Four to 10.
Just going to read that region between 4 and 10.
4 minus 8.
So 5 minus a negative 4.
So f equals 9.
Yeah.
F of 4 equals 9.
Right, so that's the first part.
Okay. And then
F prime of 7. What do you think about this one?
Not really sure where to start to get the.
Okay. So what's the name of this graph?
The F prime graph.
So can we just pick off the ordered pair then?
Well, we don't know for sure. It looks like it's -2, but we don't really know.
Well, I think we do, because if we know the slope of this line, we can kind of figure out, right?
Okay. So -1/2, right? Well, no, it's -2.
It's -2, right? And if I know that down 2 over 2 will get me down to -4, then it must land at -2, right? We don't have to guess. We just go through slope formula and just work our way down.
Exactly.
Okay. Yep, we're just pulling that information from the graph. If we know the slope, we can work our way down. Yeah, -2. It's just a point on the graph. All right. Next up is asking for F double prime of 7.
Which isn't that the slope of?
That's right. Slope of the F prime graph.
So it's just -2, right?
Yep. So if you want to use specific order pairs, or you can just count, either way works. You don't have to show the. But I'm just going to walk through the steps here. If we were to pick off some order pairs, I'll choose 8, -4, and 6, 0. But if you just count and not show the work, that's fine as well. Hey, Elliot, how are you?
I'm good.
Yeah, let me know if you have any questions as we work through this. So, okay. Part B. On what interval between -4 and 12 is the graph of F both increasing and concave up? So we understand that this is the derivative graph. So we can mark our graph here, right? Above is positive slope, below is negative slope, on the x-axis is slope 0. I'll create my slope sign line here. Extending all the way from -4 to 12. And I'm going to go ahead and set up my, well, we can wait. All right, so F prime. We can create a slope line. Anything above is going to represent positive slope. Anything below is negative slope. Anything on the x-axis are my x-intercepts. So -2, 6, and 10. Sorry, -2, 2, 6, and 10. 1, 2, 3, 4. Okay, fill in with arrows between -4 and -2. We see that region is below the x-axis, so negative, decreasing slope. Between -2 and 2, all this is above the x-axis, so positive slope. And then still, both of these are positive slopes, right? All are sitting nicely above the x-axis. From 6 to 10, this region is corresponding with below the x-axis, so negative slope. And then from 10 to 12, below the x-axis. All right, time to create our second derivative sign line. But now we want to pull information about concavity. So first we want to pick off our points of inflection. So points of inflection are just going to be the peaks and valleys of our F prime graph. So where are the points of inflections that we can place onto our concavity sign line?
0,
Okay.
2, 4, 8, 10.
Good. We just follow the slope. Whenever we see positive slope, that's going to correspond with concave up on the original graph. And they're just going to keep alternating, right? Concave up, concave down, concave up, concave down. Okay.
So wait, why do we add the x-intercepts in there also?
Because
It changes. Is it because it changes direction?
Are you talking about the 2 and the 10?
Yeah.
Because these are still peaks and valleys of the graph.
Oh, okay.
Yeah, if it's a peak or valley, it doesn't matter where it lands. If it's a peak or valley, if it's a relative max, relative min, those are technically points of inflections. Okay, so we want to know when are we going to get increasing and concave up. So we're looking for a combination of, concave up and increasing, which is, I use an arrow pointing up. So where do we see both those lined up nicely here?
on a x equals 2 interval, like 2, 4.
Yep, 2 to 4. Anywhere else?
That's, wait, -2 to 0.
Okay, there we go. I think that's it, right? Good. Right, so we'll say f of x is increasing and concave up on those two intervals because f prime is greater than 0 and f double prime is greater than 0. Okay, I'm going to show my other key that where I've already written that out. Give me a second. All right, how do you guys feel? Part B, okay?
Yep.
Okay. Next up. Part C, we have j of x equals 4x squared times g prime of 2x. Find the equation of the tangent line. So that means we have to gather information about order pair. We got to find order information about slope, and then finally point slope form. Okay, so we need to find order pair, which we already have some information about. We know x is at -1, right? We do need to find the slope. All right, where do you guys want to start?
Finding the point.
Okay, let's find the point. Just insert directly into our function here. No need for derivative. I'm just replacing all the x's that I see with -1. Four times -1 squared is just 1. All right, how do I find g prime of -2?
It's from the table.
From the table, okay, so g prime of -2.
-1.
Good. Okay. Okay, we'll set that off to the side. We know we have our order pair gathered. Next up, we need to find the slope. To find the slope, we have to first get to the what?
Derivative.
Derivative. Yeah, to get to the derivative, can we list out what procedures are involved here?
Chain, right?
Chain and
Product.
product. Okay, we'll list out product first. It's just gotta set that up. That's the big one, and then the chain rule is just that little portion there. Okay, so I'm going to write out j of x again and just label everything that I need to be doing here. Call this the F. I'll call this the G. All right, let's build this derivative here. F prime.
8x.
Okay. G, no challenge there. Just going to bring that down. F, no changes there. All right, so when we get to G prime is where we got to activate our chain rule there. So there's an outside and there's an inside portion that we got to keep track of. The outside is that G prime there. And the inside is that 2x. So we'll take turns with each derivative. All right, what's G prime going to turn into?
G double prime.
G double prime. Copy the inside exactly as you see it. Don't make any changes. So we took care of the outer's derivative. Times, what's the inner's derivative?
2.
Times 2. Good. All right, we're done with the derivative. We're done with the calculus. Any questions so far?
Nope.
Okay, so now we can start inserting our value, right? We're going to find G prime of -1, which will help lead us to our slope. We go to our table so we can make the appropriate replacements here. We need G prime of -2. We need G double prime of -2. Okay. Did you guys get 40?
Yep.
Okay.
Yep.
Good. All right. Point slope. Now we're ready. Create our tangent line equation. All right. Questions?
Nope.
Okay. All right. Part D, we have a limit problem. What's the first thing we do with a limit?
Factor it so that it's not division.
Before that, what's the first thing we always do? Every limit problem. If it's a
Plug in
approaching
and
a
see if it's undefined.
yeah, let's plug in, right? We don't know what's going on. Let's plug in. That way we can just start information gathering, do our information gathering stage, right? Let's see what's actually going on at 2. So everywhere I see an X, I'm just going to plug in. So first step. So replace every x I see with 2. Okay, we go to our table. What's g prime of 2?
-5.
-5. Okay. I'm just going to insert that. E to the -5 minus 1 over e to the 5th. And then what's g of 4?
4.
4. All right, what do we see here?
0 over 0.
0 over 0. So that is very telling. That tells us that a limit exists, but we haven't found that limit yet. There's a hole in the graph. So what special method can we do to handle this 0 over 0? Right, this is not something that we can factor, not something that we can really do anything to cancel something out. So
Would you use L'Hopital?
yeah, L'Hopital's rule. So L'Hopital's is where we find the derivative of the numerator, and then we find the derivative of the denominator. That will produce a different form. And once we get those two, the numerator and denominator adjusted, we're going to re-plug in the x value and see if that will result in something other than 0 over 0. See if that will lead us to a real number. If it does lead us to a real number, then that's our limit. Okay. So we need to take the time to find each of these derivatives. So as a reminder, the derivative for e to the u is e to the u times u prime. So what do you think the derivative of e to the g prime is going to be?
E to the g prime times g double prime.
Good. We're just following what the rule says. E to the g prime times g double prime. Okay. What does this become?
E5 e to the 5th times 0.
Yeah. You're right. Yeah. So e to the if you push that e to the 5th out as 1 over e to the 5th times, 1's derivative of 0. But you can also think of it as, well, this whole thing is a constant, so it'll just go away to 0. All right, e is just a number. Okay. So we took care of the numerator's derivative, which we will evaluate later. What about the denominator? We need to find these derivatives as well, right? So what's g of 2x's derivative?
G prime, the 2x
times
2.
2. Yep, chain rule, right? G of 2x. We got to do that outside portion versus inside portion.
Wouldn't it be g prime of 2x?
Yep. Yeah, g prime of 2x. Outside's derivative times inside's derivative. Right. My outside is g parentheses and my inside is the 2x. Chain rule. All right. What about the 4? Becomes what?
0.
0. All right. We have our derivative. Now we can reevaluate. So replace every x we see with 2, and we should be able to see if this will come down to a real number for us. G prime of 2 is just going to be -5. G double prime of 2 is 3. And G prime of 4 is -2. Do a little bit of cleanup here. Let me know if you got this answer as well.
Yep.
Okay. So that's a real number, so we can stop. We know that it's going to be the limit. Initially, it did not give us something favorable, but at least we knew where to go. We knew what to do to resolve that issue, and that's L'Hopital's rule. Okay. Good with the first page?
Yes.
All right. On page 2. Part E says, is there a time C on the closed interval from -4 to 6 such that G triple prime is equal to 2/5? All right. What does this remind you of?
Like doing like related rates with like time of like when certain things are like most like leaking out or like most time like where things are high.
Yeah, not quite. This is more of we have G double prime in front of us, but we're trying to guarantee G triple prime. So we're trying to guarantee a slope of G double prime's graph. So does that ring a bell?
Shoot.
Look at your formula sheet. Anything there that looks like something that could apply here? Okay, it's one of the theorems.
Oh,
We could do final position, initial position, or
No, not quite. Not quite. We're trying to guarantee a slope here.
average value theorem?
Say it again?
Average value theorem?
Not average value theorem. It's going to be mean value theorem. Mean value theorem allows us to guarantee a slope. We'll take a graph, and whatever slope is between the endpoints, we know there must be a slope that exists somewhere on that along that curve. Okay, so
wait, can you say that again?
yeah, so mean value theorem says this. Okay, if I have a graph, whatever the slope is between the endpoints, let's say that slope is 1/2. Is there another slope on the graph that is exactly 1/2 as well? Yes, right. We have to have a guaranteed slope of 1/2. You can imagine, right, that there must be some steepness that's going to match this dotted line exactly. And that's what mean value theorem is trying to do. It's trying to allows us to find the slope between the endpoints, and whatever slope we find between the endpoints, we can guarantee that slope is going to show up somewhere along the curve.
Okay.
Okay, so we're trying to find G triple prime though. So we're going to adapt our rule. Our rule says, well, I can guarantee a f prime of C as long as I find the slope between the endpoints. But if I want to guarantee a G triple prime, what level do I need to be looking at for my, in terms of G?
G double prime.
Good, G double prime, right? Imagine we're looking at a G double prime graph. We can guarantee that somewhere there must be a place where the slope of G double prime is going to be equal to a value. And we call that slope of G double prime, we call it G triple prime. So we're just taking mean value theorem and we're just adapting it for our problem. Okay. Questions so far?
No.
Okay, so we'll go ahead and replace all of our A and B values. And if this shows up as 2/5, then we know that there must be a 2/5 somewhere along the graph, right? But if this doesn't show up as 2/5, then maybe it does, but we can't guarantee it, not with the endpoints, right? So we're looking for, it is a very narrow success case here.
My bad.
All right, we're just going to pick off values from our table. Does this work out?
No, it's 5/2.
Mm.
Oh, I didn't do minus -4 on the bottom.
Oh, right, yeah. Can we guarantee a 2/5?
Hold on.
Is that the same thing?
No, it's 1/2 or 4/5. Jesus, I'm.
This is right. Yeah, this is right. This is yeah, 2/5. That's okay. I mean, on the quiz, you'll be able to double check yourself with the calculator. So we're good, right? We know that because my G double prime has this slope of 2/5, then there must be a place that the slope called G triple prime must be equal to 2/5 as well. So mean value theorem. So we'll say by mean value theorem, there exists a value where G triple prime is equal to 2/5.
Right.
Yeah, your expression is always going to be one level higher than what you're targeting. right? So if it's G double prime here, this will be G triple prime. If this is G prime here, this will be G double prime, right? There's always going to be staggered there, but this is always going to be one. It's going to be lower than what you're starting with. Okay, are we good with that?
Yes.
Okay. Next up, let K be the function defined by K of X equals G prime of F prime of 2X minus 1. Find K prime of 3.
This is just
Solving for the derivative of the function.
That's right. Find the derivative, and the derivative requires chain rule, right? Right, there's clearly a function within the function. Actually, there may be 3 parts here. Okay, let's see if we can identify each of them. All right, what's the outermost portion that you see?
G prime.
G prime, okay. We'll list that out. Okay, what's the next function in?
F prime minus 1.
Yep, good. Everything inside this bracket, right? Okay. F prime minus 1, good. And then there's that inner portion, which is
2x.
2x, okay, good. So this is important because if you can list these 3 parts, then you have a much better success rate of creating the correct derivative. Okay, so we'll take care of each portion one at a time. All right, let's start with the outer portion. What's G prime's derivative?
G double prime.
G double prime. And when you create G double prime, you're going to fill the bracket in with the original, no changes there. All right, we took care of the outermost portion. Questions here?
Nope.
Okay, next up, what's F prime minus 1's derivative?
Just F double prime.
Good. Minus 1's a constant, goes away, just F double prime. And then we fill the 2x, right? We're not ready for the 2x yet, but it's just going to be inside of that F double prime. All right, last part, 2x becomes
2.
2. All right, this is a tough one, so if you can do this, you'll be good for the quiz. All right, so now we gotta be careful, right? We just have to now replace every x we see with 3, and then just carefully try to resolve it down to a number. Okay. F prime of 6 minus 1.
So when we're taking like values of F prime, we just take it from the graph. So like F prime.
That's right. Yep.
0.
You're done with derivatives. We're just pulling this from the graph, but we want to pull this from the inside out, right? So you're going to work on the inside, and you're going to eventually kind of get enough information where you can get this largest outer portion.
Isn't the whole thing going to end up being 0 then? If F prime. Oh, that's F double prime right there. Never mind.
Yeah, F double. Yeah, if it had come out to be 0, I would have adjusted this. I didn't want this to be 0. I wanted this to be something that where it ends up being a number other than 0. Okay, so F prime of 6. Let's handle that first. What you guys get?
0.
Okay, yeah, so that's 0. Okay, so ends up being 0 minus 1. Okay, so the 0 goes away. I'm just left with G double prime of -1. Okay, I'm probably putting more steps than is necessary. So if we're able to do this in less steps, then no problems there. All right, so now I have everything nicely laid out. There's no more function within the function. I just need to figure out that value and multiply by 2, and I'm done. Okay, G double prime of -1.
It's -1.
Yeah, -1. Okay.
This is we took out one question,
Mm-hmm.
but I gave you a key. It's just, are you working with it tomorrow?
Yes, I am. Mm-hmm.
Okay. So this is the
Awesome. That's
key
great.
to the formative, but we
Okay.
took it after we had it done. We realized that this question was not something that we were covering. So I said, skip that one. So number
11.
I think we skipped. I want to keep that one in anyway, but I think we're not. That's not going to be part of the
I was
test.
doing this. I was like, how do I do
Like,
this?
what
I don't
the
want to do this one.
I still don't think that's the right answer.
Oh, jeez.
But it's
yeah,
the
I struggle
one-
with
that's
this. I
the way
did not know
Alex-
how to do that one.
Yeah, and I try to, but yeah. So I wrote it out, and then Ms. Stenger took it out of the
Okay.
the formative and the test before
Yeah.
we issued it.
Awesome.
And she also took that one, although I think she's having second thoughts about. But if it's gone, it's gone.
Okay.
But I kept it in the formative.
Okay. Great.
But the summative is going to look really just like that.
Okay.
Here, the wheel was already in color, so I had to write in what the colors were in order to get it.
Okay.
It's not that hard.
Awesome. Appreciate it.
But,
Thank you so
so
much.
you're going over tomorrow?
Yeah, I'll work with her tomorrow. Thank you so much.
Yeah, just let me know, and if she can do the formative in her writing, and then either give that to you or have her mom
Okay. Send it
email it to
right.
me by
Either way.
Friday, and then I'll know she's ready for the test on Friday.
Got it. Thank you so much, Bill. All right, sorry about that. Let's see. K prime of 3, -1. Okay. Do you guys get 4?
Yes.
Yes.
Okay.
So when we're doing the double prime of f, it's just the slope of that point, right? For the derivative graph, since this is the derivative graph and it's the double.
That's right. Yeah.
derivative.
If this is f prime, then f double prime is simply the slope. Yeah.
Okay. Yeah. Because I was doing it, and I was like all the way through it, and I was like, wait, what would that be? And I got this the only part I couldn't get.
Got it. Okay, good. Now you know. All right, so now part G. Find the maximum value. All right, so what does this remind you of? What special method is involved here? What did you say?
Extreme value theorem.
Yep, this is extreme value theorem, right. So extreme value theorem, that means we need to test endpoints. And we need to test critical points, but do we need to test all the critical points? Here's my slope sine line. Do I need to test -2, 2, 6, and 10?
Not all of them, because we don't have to test 2 or 6 or 10 because they're we know they're not extreme. Like
Okay.
they're not an absolute max on them.
Right. So I only care about absolute max. So I can avoid relative min. Right. Relative min has no chance. I mean, you can test it, but it's just an additional step that you don't have to do. So we only care about relative max. Right. So we only need to worry about 6. Right. 6 is the only relative extrema that has a chance of being the absolute max. Right. None of these other points has a chance. So we only need to worry about 6. Okay. Does that make sense?
Yeah.
Okay.
It could be 0 though. Don't they stop at the same spot? Wait. Never mind.
Yeah, 0 is a point of inflection. So point of inflection is kind of like a transition point. It has no chance of being a relative max or relative min. If it doesn't show up on the slope sine line, we're not even going to consider it. Okay, so just 6, right?
I was looking at the graph, not the 2.
Oh, right. Okay, yeah. So that sine line is going to be give you a better, clearer picture as to what you need to look at. Okay, so I need x equals 6. All right, EVT. I need to test -4, 12, and 6. I need to find each of their values. So I'm going to start at -4. And what do we have to do to find f of -4?
We do first theorem of calculus.
Yes. Can you be more specific? Is it just that first theorem?
You would just use the intervals. It wouldn't. Yeah, it wouldn't.
So if we just do the integral from -4 to 12, then we're only finding this portion here. Whoops, where did I have it? Yeah. Right, we're only finding the displacement, right? We also have to involve the starting point, right? So we have to go back, and anytime we're looking for a point, we got to use this final position equals initial plus displacement. If we just find the integral, then we'll figure out how far or how much progress is made, but we need to be able to anchor it with the starting point so we actually know where the graph is located. So f of b equals f of a plus the integral from a to b of f prime. All right, so what's my f of a? What's the starting point that we can use?
F of 10.
There we go. Yeah. And again, we're going backwards, right? We're starting at 10, going to -4. I realize I'm going backwards. I'm going to change that sign. F of 10 is 5 minus, in the integral from -4 to 10. So I'll total these regions up, and I'll fill these with the numbers that we've gathered from the first page. All these are just bunches of -4s and
Wait.
4s.
Oh wait, I forgot to put in the negatives.
Right, accumulation between -4 and 10.
4.
Yeah, -4 plus 8 plus 8 minus 8, just 4. Yeah. I'm sorry, it should be -12 here.
Mm-hmm.
Right.
Wait, how is it -12?
I'm sorry. I was counting wrong here. 8 plus 8. Okay.
It's 4.
Just 4, right? -4. Did you guys get 1?
Yeah.
Mm-hmm.
Okay. And messed up on my key. I need to change that later. Okay, so f of -4 is just 1. All right, next up, f of 6. Same process. My order is not correct, so I'll make the change. Okay, from 6 to 10, -8, right?
Mm-hmm.
Got 13. F of 12 is my last endpoint I need to test. Start at f of 10. Now I just need to progress from 10 to 12. And here, there's no adjustments, right? I'm already going from smaller to larger, so no need to flip this. From 10 to 12, I'm just looking at this region, which is -4. All right, so what can we conclude?
Absolute max value is 13.
Good. We only care about the y value. We could care less where that x value is. Yep.
So on the test, we don't even have to put what the x value is at all.
Nope. Just give me the y value. Yeah, I prefer that you don't give me the x value. That way, it'll just kind of train your mind. When you get to the AP exam, multiple choice, same thing. Anytime they're asking for absolute value, they just want the y value. All right. Bottom of the page. Evaluate this messy problem here. Okay, let me. I'm going to rewrite this. Maybe I can get some more clarity from that notation if I just put that in a rational exponent form. So this can be written as what? G prime of 2x to the
1/3.
1/3. Okay, so whenever you see a really messy integral problem and we don't have a rule that can handle it, then what's our option there?
U substitution.
That's right. They want students to be able to see this as a U substitution problem. And the hope is after U substitution, we'll get this down to a cleaned up version where we can actually recognize a rule that we can apply. Okay, let me write that down, U substitution. All right, so what's the U value?
2x.
A little bit more than that. We need something a little bit more.
G prime of 2x?
G prime of 2x. The reason why 2x is not going to be good enough is because if we think about letting the U value be 2x, then the there's nothing we can do to get rid of this. So there's just too much going on. We want the entire u value to be g prime because then the derivative will handle this g double prime and we can get this cleaned up, right? We don't want both of these sitting here after u substitution. We need something a lot cleaner than that. Yeah, but it's a good guess because you're looking at the parentheses, but we need something a little bit larger because of this whole mess. If this 1/3 wasn't here, or if it was just this portion, then yeah, I would say the u value is 2x. But because we have a larger mess, we need a larger u value. Right, so we're going to target this and target that. Okay, so our u value is g prime of 2x, which means that derivative du dx, what's the derivative of g prime of 2x?
G double prime 2x times 2.
Good, chain rule. G double prime 2x times 2. And that's a good sign because we want this to go away, and that should help. Cross multiply. Solve for dx. Okay, we make our substitutions. All right, what do you guys see? Does this clean up?
I cancel the g double prime 2x and then move the 1/2 out to the front.
Right, so this cleans up all the way to something that we can just do power roll with. All right. So if you went to use substitution, if it doesn't clean up to be something that is recognizable, then that chances are that means we probably didn't choose a large enough u value. But yeah, there's that 2 that still remains. We're going to push that 2 out as a 1/2. And now we have a nice and clean power roll problem. Okay, so power roll, we add 1 to the exponent, divide it by that exponent. Okay, what's my new exponent after I add 1 to this?
4/3.
4/3. And we divide it by that same 4/3. Do a little bit of cleanup here. That becomes 3/8. Okay, we know we have to involve bounds, but I think maybe a little bit cleaner. It's just let's just get this back in terms of x. That way we don't have to change the bounds. So I'm going to replace the u back in terms of x, which is my original u substitution. So it's going to be this whole thing here. Oops, not g double prime, just g prime. Now we have the antiderivative, up to the 4/3. And we can cleanly evaluate this between -3 and -1. Upper bound gets plugged in first. Now, as soon as we get this down to a number, to a numeric expression, then we can stop. We don't have to, I don't want you guys to simplify, right? If you just get it down to a number, that's all I care about here. So let me get this a little bit cleaner here. Go to our table, G prime of 6 is 1. G prime of -2.
-1.
-1. No, it's actually not, oh, actually, yeah, wow, this actually ends up just being 0, right? I can leave it in this form. Yeah, that's a tough one. If you understand the process, that's what I'm after. All right, last page. Do you guys still need to look at this, or you're good?
I'm good.
Okay. All right, find the average value of f prime. So we have average value theorem, and that's all we need to use. So let me write out what average value theorem is, and then we can adapt it for this problem here. So on the formula sheet, average value theorem. F of c equals 1 over b minus a, integral from a to b of f of x. However, we're trying to find the average value of f prime, so we need to adjust these to be f primes. Okay, we want to find the average value of f prime. So we have our a and b values, -2 and 8. Okay, and we just insert everything in and see how our graph can help us out. All right, so -2 to 8 of f prime.
It's 12.
Good. Oops, +4. Eight plus 8 is 16. 16 minus 4 is 12. So the average height amongst this region is going to be a height of 6/5. Okay, good so far?
Yep.
All right. Look at J here. The wording is kind of similar, but it's very different. It says find the average rate of change of f prime. So this is not the same thing as average value. So average rate of change, another word for that is what?
Slope.
That's right. Find slope between endpoints. So change in f prime over the change in time. F prime of 8, we're just pulling this from our table here. Oh, sorry, not from a table, from our graph. Okay, what's f prime of 8 equal to?
-4.
-4, okay. F prime of 1.
2.
2, right? All right. Good there.
Yeah. Going from the ones we did on page 2 to this one.
Yeah, I know. All right. Last one, part K. Find the values of P of 1 and P prime of 1. Okay, let's start with the easier one. P of 1, we're just entering this into the formula. Replace 1 in for x, -2 to 3. But we're just finding the area here up to 3. So it's just going to be this little triangle here. So 1/2 base times height, 1/2 1 times 2. That's just equal to 1. So that's this little portion is just equal to 1. All right, you guys good with that?
Yep.
Okay, 4 plus 4 plus 1 is 9. Next up, I need to find P prime of 1, but before I get to P prime of 1, I'm going to spend my time finding P prime of x. So if I want to find P prime of x, I need to find the derivative of this mess. That's an application of second theorem. So let's create what P prime could look like here. P prime is simply the derivative of this right side. So I'm just going to follow the rule. The rule just tells me to insert the upper bound into the function and multiply it by the upper bound's derivative. So insert the upper bound into the variable, so f prime of 3x times, what's upper bound's derivative?
3.
There's 3. All right, so now we're ready. P prime of 1 f prime of 3 is equal to two as well, right? You guys good with that?
Yep.
Yeah. So I encourage you guys to, look for these other problems that are on the other sheets, because, these are problems that are types are going to show up, but it's going to be shorter than this. It's going to be like 7 parts instead of 10 that you see in front of you. But you should feel pretty good seeing all that. You'll have notes in front of you, so, everything is going to be lined up very similar to how I'm setting these up. So if you know the first steps, that will kind of take you a long way.
Is it gonna be more like what we just did with like a graph rather than just when like no graph, just word problem, like some of the examples on the antiderivative FRQs?
No, it's literally going to look like this.
Oh, okay.
Like I created the quiz first, and then I created this morning review off the quiz.
Oh.
Yeah, so I'm like, I probably made this more difficult than the quiz so that you guys can, feel strong about this and then make it slightly easier for the quiz. But literally, this is off the template of the quiz. So
Okay.
if you can do this, you should be good. There's no surprises off of this review. Yeah, I mean, for the quiz, I mean, you're literally going to be able to define a matching part for you to see your work. So.
Thank you, Mr. Yang.
Yeah, thanks for being here. Because if you weren't here, I wouldn't be able to create the video. So, but yeah, hopefully you guys feel good and you'll do well tomorrow. So.
Thank you.
All right, thanks, guys. See you tomorrow.
So I left my baseball bag in one of my teacher's classrooms.